the MOU in 2022 with the TSMC, and they have creating one foundry. This is in Dholera, Gujarat. Okay, I think they will be starting 2026 with some production. SCL production are there. Then we have used the 100 nanometer technology. Okay, we have the one project from the ISRO. There we have to fabricated the chip in SCL Chandigarh, and that will be using Chandrayaan 3. That will be shown later of this activity. Okay, the roadmap of 2025 till this is 1999. This will be 76, but here at 2026, this value is going to increase up the 400. Now it will be more than 400 will be. Making India a global hub of electronic manufacturing, 25 billion in the fiscal support. Okay, we have young manpowers, but due to the policy of the government, we are not able to run. In 1950, Rajiv Gandhi have come with the computers. There are so many people had to be against that. When computer will come, job will gone. But nowadays, have any job without computer? No. If you doesn't know, if you know about, do not know about the computers, you have no job. Okay, either any sectors. Every sector should be required the computer knowledge, except the requirement. Okay. So now it's getting incentives and insensitive to or insensitive. So here the SMT components, active, passive, PCB, electromechanical, sensor, transducer, crystal, MEMS, RAMs, ATMP, product assembly capacity. And some assembly will find camera modules, vibrator, data capable mechanics, display assembly, capex link, advanced chemical cell, production link, is a PLI, and finished goods like mobile phones, tablets, servers, laptops, all-in-one PCs, production link. Okay, so that assembling part we are doing in India. Okay, now few days back, one private limited foundry is going to start in Noida. The Prime Minister and Modi ji have to be inaugurated. There will support of I think SCL and some other outside the country. The PLI scheme for a large-scale electronics manufacturing. Now you see, these are the players, marketing, like a Foxconn, Pegatron, Rising Star, Wistron, Lava. They are all the Indian companies. Okay. Now, in have Exilia Group, Comet AZ, Eton Corporation, Phoenix Meco, India have global capacitor, Dickey Electronics, CDIL, Iberwala, Epitone, like that. In Japan have Hiju Electronics. Just so you have to find the server in your lab if you have that. Renisha, Roham, Taiyuin, PDK Corporation. In Taiwan have Relic Electronics, Chelishin, Impact, ACE, Anjit, Nanya PCB, Passive System Alliance. In United States have Amco, Diodes, Genesec, ABKX, Standex, Linux, Bell Fuse, Benmark, so on. Telecom sectors. Now we have discussed on our products, what we have done in the chip designing. This is a CMOS temperature sensors, schematic design of CMOS temperature using Cadence SCL PDK 180 technology. This PDK library we have to taken from the SCL Chandigarh, what I discussed with you. And this temperature is CMOS. And we have to be design this sensors in the competition of the Texas Instrument. Texas Instrument 2 volt power supply. This is a very low. That is known as a low power design. Okay. So now if you see, this is your layout of this sensors. Okay, because for that one you have required some STEM circuitry. We have shown the internal component what will be inside of the chip. Okay, so this is actual your chip. So this is transistors, whatever shown you are. This is PMOS, PMOS. This is NMOS, and these transistors have, you see, this is the work as a active resistors. This is PMOS, and here this is the work as a current mirror. Who are in design, know about the design, they understand what is the importance of current mirror. If you go for a design that your W/L ratio will be compensated by this current mirror. If current mirror facility will not be there, it is very difficult to design the analog circuit. Okay, W/L ratio is a known aspect ratio, is very helpful in your digital design as well. Okay, so this is your chip, this is your layout of CMOS temperature sensors, and this is the packaging portions. Okay, this is, you can say, this is a corner pads, This one is corner pad. This is your side pads. Okay. Here below is so we have required the three pins. One is VDD, one other is V out, another is we have required the ground. And in the round portion, this chip will be set. Okay. And this red colors, this is known as a metal 2. Okay. So now you see this complete chip over here. This is a seal ring who have if people find in the foundry, then will find this is seal ring. This is your dummy field. Why require the dummy field? This is pad, seal ring, silicon numbers. Because if you go to fabrication, then you have not only single IC, we have billion of IC are there. Okay. So with the silicon numbers, you are able to identify your IC. And here your will be chip will be set. Here dummy field, what do you mean by dummy field? Dummy field is required. If you not fill that, then your IC will be sorted. Okay, when you have to go for metallization, all the metals will be expanded. All this portion of the your chip, and that will be your chip will be sorted. Okay, you see this red color is shown as a dummy field, and here will be chip, here will be chip, here all the three chips will be there, three sensors will be there. Okay, and all will be isolated. So when you will do the etching, this portion will be etched. And if dummy field will be etched, that color will be etched, and your actual IC will be there. Okay. Now you see this my temperature sensor is working minus 20 to 120 in terms of NTC, negative temperature coefficient. As temperature is increases, the value is decreasing. You see this my temperature sensor is fabricated by SCL Chandigarh, a semiconductor laboratory. This seal sign and mower is everything is given by the SCL Chandigarh. They are fabricated, packaged, and then delivered to ISRO, and ISRO have used in your Chandrayaan 3, and that is IC is known as EDU 129. हमारे IC का नाम है EDU 129. Okay, you see this is IC. The same way, after the packaging, when IC we have given number. With the number we have to recognize. This is 7400. You have to recognize the IC with the number. Similarly, here you will be recognize the EDU 129. Okay, thank you. Now we have come to what the government is doing. Just will be show you.
Thank you, sir, for technological.
No, 1 minute actually have some. Hello, Shekhar.
Yes, sir.
1 minute, I'm just showing the video. Okay.
Okay.
I'm sharing some video. Now my screen is visible.
Yes, sir, it's visible. Yes, sir, it's visible.
Voice is coming.
Every great
Voice is coming.
Yes, sir. Yes, sir. All okay.
Okay.
revolution starts with a spark that spreads its energy. changes the landscape around it forever. The tiny silicon mass that beat at the heart of every device. Semiconductors are the new oil, powering intelligence. In the last 10 years, under Prime Minister Shri Narendra Modi's vision of exponential growth in India's electronics manufacturing sector, India's semiconductor market is projected to reach 110 billion US dollar by 2030 in the 1 trillion US dollar global semiconductor market. India's semiconductor mission started with launch of Semicon India program in December 2021 with a vision of a global partner in the semiconductor supply chain. This landmark initiative marked a turning point for India's transformation into a global semiconductor hub. The DLI scheme empowers domestic companies with support up to 50% cost for chip design and 6 to 4% of net sales turnover, along with EDA tools, third-party IP cores, and post-STI validation.
हमारा सपना है कि दुनिया की हर डिवाइस में इंडियन मेड चिप हो.
10 projects approved. These include Silicon Fab, Silicon Carbide Fab, and 8 packaging facilities producing 24 billion chips annually. With focused investments, policy support, and collaboration across industry and academia, India's semiconductor revolution is taking shape across the country. There are 20% of the startups have been approved for designing semiconductor chips. 60,000 students trained under the Chips to Startup program. Together with Design-Linked Initiative Scheme, electronic design automation tools provided to over 280 plus institutes and 72 startups, making it the world's largest centralized EDA tools facility provided to students. These transformative projects will open up thousands of new job opportunities for startups, technicians, and engineers. Revised semiconductor curriculum implemented by AICTE in more than 500 institutes, MOUs and MOCs with the US, Japan, Singapore, and the EU. Partnerships with multiple countries for R&D and workforce development. Under New Bharat, industry will be encouraged to do R&D and setting up manufacturing facilities for equipment, semiconductor-grade chemicals, gases, and materials for the development of complete ecosystem.
और अब भारत अगले 25 वर्षों के लक्ष्य पर काम कर रहा है.
From spark to silicon, from ambition to achievement, Bharat is rising and emerging as a reliable and trusted partner in global supply chains. This is Bharat, building the next semiconductor powerhouse. Jai Hind.
Yeah, everyone's seen what the India government is doing and what is the job opportunity for our youngsters and what type of skills would be required for your chip design. I hope everyone have to enjoy this lectures, videos, and you have to be conscious about that and you have to prepare yourself. Now the time of your question and sessions. Have any doubt, anything you are willing to ask, you can go ahead.
Thank you, sir. Thank you, sir, for planning the experience. Thank you, sir.
Your voice is not coming.
Thank you so much, sir.
Thank you. Yeah, there are several students are sitting in the hall. Please ask the questions.
Anyone have a question?
Does anyone have a question? You can ask.
Gaurav Chatterjee, on your mic. Yeah.
Yes, yes. Hi. Hello, sir.
Yes. Have any questions from your side?
No, as of now, no.
Okay. But everyone take the interest and do that. This is very informative and it is very useful course for your tomorrow and today also.
Okay. Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.
Our final keynote speaker brings a strong industrial perspective to the evolving field of artificial intelligence. Engineer Gaurav Chatterjee, Assistant Manager, Data Science at Tata works at the intersection of data analytics, AI deployment, and real-world industrial applications. As AI systems increasingly influence healthcare, communication, accessibility tools, and AI technologies, ethical design and human-centered algorithms become critical. We will conclude our keynote series with the topic AI for Intelligence, from algorithms to human technology. May I please invite Engineer Gaurav Chatterjee to enlighten us with his keynote session. Thank you.
Thank
Please
you.
proceed. Please proceed, sir.
Yes, yes. Just a minute.
Okay, Chandrasekhar, I can leave it.
Yes, sir. Sure. Thank you so much, sir.
Is my screen visible?
Yes, sir.
Okay.
You are visible.
Okay, so yeah, first of all, I'm very grateful that I have been invited here as a keynote speaker to an institution where, uh, as I have done some research and got to know that this institution is one of the first institutions to make inclusive education, which is very impressive and which is very much needed now. Okay, so now is my voice and everything clear, guys?
Yes, sir.
Okay, okay. Now shall start?
Yes. Yes, sir.
So okay, so a bit about me first. Thank you so much for introducing me. It's just a small introduction again that my name is Gaurav Chatterjee. I am working as an assistant manager at Rakuten, Japan. I'm based in Tokyo right now. I lead a team of data scientists and we are working on some cutting edge technologies like LLMs. And we are trying to build some algorithms and some systems which are smart enough to handle telecom data. And also we are putting lots of data science into telecom to get insights out of the data to provide business knowledge to our executives like CEOs and CTOs. I have 7 years of experience in the field of data and AI, and I'm very passionate about machine learning and AI because it gives me instant gratification. Because when you implement something and you're able to see that it's adding value to a person's life, you get gratification, right? So that's what I got from this field, and I chose it, and then I'm continuing in this field. Also, I'm an avid writer. Uh, Especially on LinkedIn, I write about my personal journey, how it went from my college days to where I am right now, and about technical stuff, about non-technical stuff. So you can follow me on LinkedIn. More about that later. I play guitar, and in winters I do snowboarding. As you can see here, this is me. Okay, so today's topic is AI for inclusion, and I think nobody can better understand AI inclusion uh, compared to you guys. So you understand it really well because among uh, all of you, there are people who are specially able and they are learning with you. So let's talk about AI for inclusion, from algorithms to human empowerment. So there's this question which bothered me, that what if the world wasn't designed for you? And I will let it sink in your heads for some time, and I'll let it find the meaning inside your head, that what if the world wasn't designed for you? And I'll just quickly show you one video which inspired me a lot in taking up the machine learning path, AI and machine learning path. So just quickly tell me if the video and the voice is clear. Is it clear?
Yes. Sir, video is clear. Please play and to confirm voice.
I am
Yes,
Is
sir.
it clear?
Voice and videos both are clear.
Amazing, amazing. So I'm just playing it.
Hi, I am Tanya. This is my voice. I use Morse code by inputting dots and dashes with switches mounted near my head. As a very young child, I used a communication word board. I used a head stick to point to the words. It was very attractive, to say the least. Once Morse code was incorporated into my life, it was a feeling of pure liberation and freedom. I think that is why I like skydiving so much. It is the same kind of feeling. Through skydiving, I met Ken, the love of my life, and partner in crime.
It's always been very, very difficult just to find Morse code devices, to try Morse code.
This is why I had to create my own. With the help from Ken, I have a voice and more independence in my daily life. But most people don't have Ken. It is our hope that we can collaborate with the Gboard team to help people who want to tap into the freedom of using Morse code.
Gboard is the Google keyboard. What we have discovered working on Gboard is that there are entire pockets of population in the world, and when I say pockets, it's like tens of millions of people who have never had access to a keyboard that works in their own language. With Tanya, we've built support in Gboard for Morse code. It's an input modality that allows you to type in Morse code and get text out with predictions, suggestions. I think it's a beautiful example of where machine learning can really assist someone in a way that a normal keyboard without artificial intelligence wouldn't be able to.
I am very excited to continue on this journey. Many people will benefit from this, and that thrills me to no end.
Okay, how was it? Was it inspiring? I mean, when I saw this, I was like, okay, I have to do something in the space of AI. Hello, is it audible?
Yes.
Okay,
You are audible.
cool. So when I saw this, I was very inspired, and this thought came into my mind that AI can help the world become more inclusive if we think in that direction. But there is a small problem here. The problem is that there are now there are 1.3 billion people globally living with disabilities, which is 16% of the population. And for them, we are not thinking, because we are thinking about majority, and that's what, like, statistically we do. Like, we know that this is a huge majority of people, and if we create something, it will fly for them, for a huge majority. But what about those 1.3 billion people, which in number is huge? It's huge, but statistically speaking, it's 16%, which is again huge, but it's not majority. So we have to do something about it, and we have to build inclusive AI for them, because the digital divide is real. Now, I will tell you with an example how a digital divide happens. Let's say, for example, a class is there, and in front of that class, there is a AI fitted camera is present. And that AI fitted camera's whole purpose is to mark attendance. And whenever there's a normal guy passes, the AI fitted camera marks his or her attendance perfectly. But whenever a disabled person, let's imagine a person on a wheelchair passes, the camera doesn't mark the attendance. So that's how you can see that the digital divide is real. It's doing some kind of discrimination. And why is it doing that kind of discrimination? We'll further study about it. But what exactly is inclusive AI? Let's first understand that. So the definition of inclusive AI is the AI systems designed to reduce barriers, not create new ones. And the key pillars, in my opinion, are accessibility, fairness, and representation in data sets. Now, what is accessibility? It simply means that whatever AI application you are creating, it is getting used by diverse people with diverse abilities. Let's say in the last example we have gone through this, that people with normal walking abilities are getting marked in the attendance, but people on a wheelchair are not getting marked. So accessibility is that, okay, so whatever AI applications we are creating, it should be accessible to diverse abilities people. And then comes fairness. Okay, before we move forward, I will give you a bad example of accessibility. How can accessibility, uh, how can an AI application becomes inaccessible? So when you design, so there's voice systems from companies like Apple and Google historically suggested struggled with non-American accents. So those voice systems in Apple and Google, they were struggling with non-American accents. They were struggling with speech impairments and stuttering. So these kind of voices, they were not able to process well. And it impacted elderly users, because we all know that they have the stutter, and non-native speakers, like the people who don't have accent, American accent like us, and the people with speech disorders. So this is a very bad example of accessibility. You can call it inaccessible, making an AI system which is inaccessible to the diverse ability, people with diverse ability. Now come to the fairness. So fairness, as you all might have guessed, that we have to prevent biases and ensuring equal outcomes for all users. Now I'll tell you the bad example of it, that studies shows higher error rate in systems from companies like IBM and others when identifying darker skinned women compared to lighter skinned men. And it happens because it happened earlier because data was imbalanced, more white male than the black females, and it led to real world arrests and discriminations. Uh, Now that we have understood that how important and crucial it is for us to make our data set in a representable manner, so we have to ensure that diverse and accurate data is provided to the algorithms. And that's the third point, representation in data set, which is saying ensuring diverse and accurate data to avoid algorithmic discriminations. Now, the problem when AI excludes, I already talked about facial recognition biases, the black women and white male example. voice system failing with speech impairments, we have talked about it. And the third one is language models not supporting low resource languages. Let's say earlier, many models were not supporting Hindi or Devanagari or the languages which are not there in West, because all the new innovations were earlier coming from West. So they have excluded those languages. And excluding those languages means excluding billions of speakers, which is not right in a manner. And the key concept is if you put garbage in, you will get bias out. So this exclusion stems from dataset imbalance, algorithmic bias, and lack of diversity in AI teams, as we have already discussed. Now, I have talked about the bad examples of AI, inclusive AI, like non-inclusive AI. Let's talk about some good examples of inclusive AI and real-world examples like live captions on Google products, AI-powered screen readers, eye tracking systems. In healthcare, we have AI detecting diseases in rural area. In communication, we have speech to text, sign language recognition. So now that we have come to sign language recognition, for this presentation, I have created a small demo and I quickly made it to inspire you guys. So the next slide is sign language recognition done upon me. It doesn't have audio, so uh, it's fine. Don't bother about that. As you can see that I'm doing sign languages, and the AI is able to detect my signs. So you can imagine that in a system where a person is not able to speak, and we all cannot understand sign language, right? So they might have a screen or something which on which if they do these kind of signs, hand signs, the uh, the display screen shows the words or the sentences which they want to say, or the device outputs the voice. So sign languages, and the input is sign languages, the machine learning processes it, and the output is voice. It would be very easy for normal people to understand uh, people with disabilities in this way. So this is a huge uh, step towards inclusive AI. So how I have created this demo and how you can also create. First of all, my framework is I define problems. The problem here was many deaf individuals rely on sign language, so we have to do something about them. The technical approach is, of course, when you're training machine learning model, you have to collect data, you have to pre-process images, feed it into transformers. You have to think about real-time interface, like this interface was a real-time interface. So I cannot show you live because my camera is already in use. Otherwise, I would have shown you live. This is live, live. I mean, like if I turn on my camera, with this algorithm in the backend, it will be able to detect me on live. So real-time interface and then edge deployment possibilities. So right now this is on my laptop. If I want to deploy it in an edge device where the whole algorithm is on top of the device which is installed somewhere, then it's called edge deployment possibilities. And the impact it can create, it's like unmeasurable. It can impact education, it can impact customer service, it can impact emergency responses, and you can think a lot of areas which it can create impact on. So when you design an algorithm, I would suggest, of course, what we do is the first layer is accuracy of the model and the models itself and the optimization. The second layer is deployment. hardware constraints, latency, but there should be a human angle too, which is the application which you are developing. Is it restoring the dignity of the people around you or who are vulnerable, more vulnerable than us? Is it increasing the independence? Is it reducing the dependency? So there must be some kind of human level, emotional level reasoning behind creation of an application. Personally, when I think about it, it motivates me to work harder and create more applications like this. Now, the future of AI includes brain computer interfaces, AI prosthetics, real time translations, edge AI on smartphones, generative AI for assistive content, and many more. So, the main motivation for me to talk about inclusive AI is that if we don't think about solutions and algorithms for the people, for that 16% of the people, it is very difficult for them to survive. I mean, like, it won't be difficult for them to survive, but when we can make their life easier, why not? Because those 16% of the people probabilistically are less. So we as a majority can think about it and then develop something to help them. And of course, they are self-sufficient. They can think about these solutions. They can implement it too. And that's what the institution, your institution, is empowering uh, people with special abilities. And the leading organizations are OpenAI, multimodal accessibility tools, and Google accessibility research, Microsoft inclusive AI initiatives. These are some initiatives which are already going on. Now, the true measure of intelligence, whether it be artificial or human, is how well it uplifts the most vulnerable among us. So AI is not just about building smarter machines, it's about building a more inclusive world. This is, in my opinion, this is the last slide. It's a concluding slide. If there are any questions, you feel free to reach out to me on LinkedIn. Also, this is my personal website. You can take a note of it. Right now, also, you can ask questions. This was a small but very important um message and presentation from my side. Yes, thank you so much. Let's come back to the screen. Yep. Okay. So, guys, do you have any questions? Was it understandable? Was it non-understandable? Back from you guys. You cannot be bluffing with me. A guy sitting in Tokyo doing lecture for you. Don't bluff with me. Ask me questions. I mean, come on.
No questions.
Okay, yeah.
आराम से
In current time, many companies are making a lot of algorithms and other stuff. So my question was, what is the future of AI and algorithms?
Google, Amazon, and these all big tech companies didn't lay off right now. It can be because of AI, it can be because of other factors. But right now, what I can think of is how I am personally securing my position and not only relying on code. I'm relying on systems. I have to combine all of them together and make a product which is giving business value. And because I stayed in a telecom network, right now I'm in Rakuten Mobile, I stayed in a telecom network for like 4 years right now. I know lots of nitty-gritties, and I can mix those systems together to create a system design which can serve and solve a business problem, which in a very niche manner right now AI is not able to do, to be very honest. So I'm not focusing on coding only. I'm focusing on how to solve a problem. So that's my opinion on.
Sir, my second question was on quantum algorithms, that how it is actually, as you know that how India is doing in quantum world.
Think processing would be way faster than the normal GPUs, and it can like process like in seconds multi terabytes of data, which can be a little daunting, to be very honest, to think about. And right now I can think of thinking in a critical way manner so that you can avoid that particular situation. So see, to be very honest, uh, things are changing very fast. When I was, the new updates on AI used to be like coming in 6 months, 1 year, 3 year, like that. But right now, whenever I open LinkedIn or whenever I open right now, and
I have seen a post of Andrew Kabad. I think the AI is evolving in its own state.
yeah, he left too. Right now, I everyone left. So yeah, not sure how it will go, but yeah, I will just give you an advice of think instead of just coding or just doing dockerization, very niche problems, don't think about it. Think about whole.
Answer one more have.
Sure.
Whether using that particular system which is utilize the AI. So, is there any chance we are using the neuromorphic computing based systems using that particular coding? Neuromorphic computing, I think, it's related to the spiking neural network.
Sorry, can you come again? Neuromorphic.
Neuromorphic.
What was the question again?
Is I'm using this type of coding related to the sign language, sign based. So AI is converted neuromorphic computing is something we're converting the AI based model into our system.
There's something called BMI, brain. Brain machine interface. Yeah, BMI is brain machine interface. So when you put that electrons out of your brain, so what it can do is it can understand those signals, it can distinguish those signals, and it can like output whatever you were trying to think. And I have seen a couple of videos where they were telepathically talking. So there was no voice output, there was only signal output. So there were two people, and each of them were wearing this device which can get the signals out of your brain and convert it into English language. And that's how they were communicating. So it's a telepathic kind of a communication. And when I saw it was hilarious to see. So yeah, yeah. Keep positive. It's happening actually. There are many things which are happening right now, which is very incredible to see.
Thank you, sir. Thank you, sir.
Any other questions?
Please.
There is one more question, sir.
Yeah, sure.
Actually, I have developed an ASL file language recognition system around 5 months ago, and I got faced a problem. That was the overlapping of multiple files. So may I know your approach about that?
Your voice is not audible properly. Can you repeat the question?
I'm saying, sir, that while making the program for ASL recognition system, I faced the problem of overlapping multiple files.
Overlapping multiple signs. Okay. So basically, I could think about a solution where you can. Which model are you using, by the way?
Model.
I mean, you are talking about recognizing sign language, right?
Yes, sir.
You trained it yourself. Sorry. Understood. Also face this challenge that there are overlaps. So what you can do is you can wear something which is a little distinguishable. So like, let's say you wear a glove of green color or violet color, which distinguishes your hand, your palm, from is of the same color of your palm. So you have to the model, the AI is able to distinguish some distinguishing gloves and train the model. In this way, I think it will perform better.
While using Biorehab and OpenCV, I use the different 15 points that are and between your hand fingers, etc. So in that, like I and J are both searching for that. Sometimes overlap. Sometimes it goes I, sometimes it goes J. So how can I?
Okay, so that thing is you have to find out different ways of representing. So the machine is a bunch of pattern recognition algorithms. So if you're telling this is I and the J is different, J is again the same, then it will be confusing, of course. So right now you're saying this is I, what is J? Yeah. So are you using some kind of gloves to train your model?
Yes, I use some kind of gloves to distinguish between fingers, but it didn't work.
Take another approach. Yeah, it's like you have to kind of make a little more different representation. Maybe you can put this with this. It can recognize as T, but yeah, you have to find a
The problem is that in exercise, everything is predefined. You can't change that.
That's the problem. That's absolutely the problem. Yeah. Then in that manner, we have to put more training data. We cannot do much more into it. We have to put more I and J, particularly those things, as more training data to the model to train. How many images are you training for each letter?
When this one working, so I trained that myself. I coded each and every line, and then I in 26 letters, 21 letters were obviously around 95 to 98% accurate, but for 4 letters it was around 40 to 60%.
So are you using only OpenCV and okay. Yeah.
So for model training, I was using teachable machine.
Sorry?
Teachable machine. A site that used to train models.
Okay. Okay. I mean, these are production ready, but yeah, I mean, like with OpenAI, maybe we can do something. Have you tried OpenAI for recognitions?
Yes, sir. Yes, I did. That was almost same.
No, I mean, okay. Yeah, I think right now I cannot think of any solutions as on the fly, but yeah, we can connect and we can talk more about it. Thank you. Any other questions?
No, sir. No, sir.
Okay. Great.
Another team benefit research.
Sorry, your voice is very feeble. Not able to.
Thank you so much, sir.
Thank you so much, sir, for providing the practical and actionable guide that will undoubtedly benefit our research community. Thank you.
Sure. Thank you. Okay. Have a great day, guys.
Respected dignitaries, honorable speakers, distinguished guests, faculty members, dear research scholars, students, and all present here. As we come to the end of this enlightening keyword speaker session of Biorehab 2026, it truly feels inspiring to reflect upon the wealth of knowledge and insights shared with us today. From advancements in cybersecurity, AI-driven chip design, biomedical innovations, communication technologies, IoT and healthcare, to smart rehab technologies. Each session expanded our perspective and deepened our understanding of how technology is transforming life. On behalf of Department of ECE, Dr. Shakula Mishra, National Education University, I extend my heartfelt gratitude to our esteemed keynote speakers, our honorable dignitaries for gracing the occasion, the organizing committee for their dedicated efforts, the integral ensuring inclusive communication from all our very prepared students, and of course, all participants and attendees for your active presence and enthusiasm. Your contribution has made it